All right, so this is now the next step with derivatives, which is we're going to introduce it with an addition or subtraction, with product rule, and with quotient rule. And then we'll put it all together. So let's start with our basics. So if you see an addition or a subtraction, same rules apply. We just take derivatives of the parts. So derivative cosine would be negative sine x, and derivative cosine x would be cosine x. And so that is what we get, negative sine x minus cosine x. And you can factor out the negative if you want and put sine plus cosine. Product rule, we do the same thing. So you find the x's. You can see that there is an x in the first part. You put a dot. And so the 3x cubed would go first. That's your f. And your sine x would be your g. So f equals 3x cubed. G equals sine x. So f prime would be 9x squared. And g prime would be cosine x. And then we do our multiply just like before. Little cross multiply. And so we get y prime equals, don't forget the y prime, 9x squared sine x plus, and then 3x cubed cosine x, just like that. And there we go. And we can factor out the x squared if we want, but I'm going to leave it the way it is. So this becomes 9x squared sine x plus 3x cubed cosine x. So like I was saying, you can factor out that 3x squared, and you end up with 3 sine x plus x cosine x. Either one is fine. And with quotient rule, same thing. So the top, there's supposed to be an x there. The top is sine x. The bottom is 1 minus cosine x. So f prime would be cosine x. G prime would be sine x, because again, derivative of cosine. 1 is 0, so that's going to disappear. And then derivative of cosine would be negative sine, but that negative turns it into a positive. And then remember, with quotient, it's very important to always start with the first one. So our y prime equals cosine x times 1 minus cosine x minus, and then sine x times sine x, all over 1 minus cosine x squared. Okay, so we get y prime equals, and we distribute cosine x minus cosine squared x minus sine squared x over 1 minus cosine x squared. Now, if you remember our Pythagorean identities, anytime you see a sine squared and cosine squared next to each other, we try to combine them. Now, they both have a minus, so we can take that and put minus sine squared x plus cosine squared x, and that becomes 1. And so this becomes cosine x minus 1 over 1 minus cosine squared, cosine x squared. And then if we flip that, we get negative 1 minus cosine x, like that, and then we double check the sign. So negative 1 plus cosine x, it checks. And the reason I'm doing that is because on the bottom, we also have a 1 minus cosine x. And so that would allow us to cancel one of them, giving us negative 1. So on some of these, you will still need to use your trig identities. And so we could keep going and do 1 plus cosine x top and bottom, and then change that into a sine squared on the bottom, and then switch it over. But I think we'll stop there. There's more that we could do to it. All right, so all together, if you see pluses and minuses, then y prime would equal, and derivative secant is secant x, and don't forget that secant's a child, so he needs his father. And this is 2 secants. And then the last one, this is a product. You can see there are 2 x's being multiplied, cosecant x and secant x, so that is product rule. So we're going to do that off to the side. F equals cosecant x, g equals secant x. And so f prime would be cosecant x cotangent x, because they need their fathers, and g prime would be secant x tangent x. And then we just do our little product rule. So this times this. So we get cosecant x cotangent x secant x plus, and then secant x tangent x cosecant x And they all have a secant, so we could place them over here and then cancel them out. But you also see that this is 1 over sine x. This is cosine x over sine x. So we should really check them. And you can see that cancels. So we end up with 1 over sine squared x, which is cosecant squared x. And then the other one is 1 over cosine x, and then sine x over cosine x times 1 over sine x. And again, those cancel. So we get 1 over cosine squared x, so plus, plus, and so that would be secant squared x. So we can place those in there, cosecant squared x plus secant squared x. And we can keep modifying this some more if we want, but we're going to stop. So this is secant x tangent x plus 2 secant squared x's minus cosecant squared x's. There are other options on how you simplify this. We could keep going with each of these, but we'll stop there. All right, thank you.